Hello everyone, welcome to lecture 26. Today we will talk about the glacial lake vulnerability assessment. This lecture belongs to the module 7 and today we will learn about the vulnerability assessment. So let us start from the basic. What is a glacial lake? So a glacial lake is a body of water with origin from glacier activities, right? They are formed when a glacier erodes the land and then melts, filling the depression created by glaciers. And here you can see some of the examples so that you can understand what we exactly mean by glacial lakes. And these glacial lakes are often dammed by the moraines or ice. So here you can see the example of moraines. So here this is the moraine which is holding this particular water, right, which is coming from these glaciers. And in this case you can see some of the ice, they are acting as a barrier and then this water will be accumulated. So these are the two different types of glacial lakes, and here this is another example where glacier flow is there in this direction and here it starts melting and the depression is getting filled with the glacier melt water, right. So a glacial lake is a body of water that originates from glacial activities. These lakes frequently form at the terminus or foot of a glacier. However, they can also develop on the glacier surface, inside the ice itself or underneath it. So I hope you remember the different types of glacier, supraglacier and other forms were there. So here this is one of the type. With changing climatic conditions, glaciers are retreating rapidly, leading to increased freshwater accumulation in glacial lakes. These are again the different types of glacial lakes from different location, and the glacial lakes have grown rapidly around the world in the last 3 decades, showing the impact of increased melt water. So ultimately the water which is coming to these glacial lakes are from the melt, right, and it is because of the changing climatic condition. And then we have also understood in the previous few lectures that how important it is to understand the process and then associated hazards and how they can impact our livelihood. This is one example which shows the importance of the monitoring of the glacial lakes. So this is from South Lonak, and this lake particularly, you see there was a breach here, the Glof event. So this is the before breach and this is the after breach. So once we have the advantage of satellite images with us, we can have the continuous monitoring of the given glacial lakes. So let us try to understand the importance of the remote sensing in cryospheric hazards. So particularly it has a large aerial coverage which is very important. Then the data information which we are gathering through remote sensing, it is non-destructive in nature. That means it is not disturbing the area which is acquired by the sensor. So we are not disturbing the sample. With remote sensing, with advancement in the technology, we have high spatial, spectral and temporal images. And access to inaccessible areas, that is another advantage of remote sensing data. Then real time or near real time data sets are also available. So we see different images available in the archives of the corresponding space agencies. So these data sets can be referred to study these kind of temporal changes in the glacial lake boundaries. Wide range of data across the wavelength, because you know that higher altitudes are having cloud cover, so optical data sets are not useful. Then we move towards the microwave remote sensing domain, and that can be utilized here. Then comes the systematic and repetitive data collection. If you want to correlate or you want to go for the change detection, these remote sensing satellite images are very useful, because they are in the same format and they are also having the geotagged location that helps us to analyze the temporal changes in a given area, particularly here in this case glacial lake boundaries, right. So, here you can see this is an example from Sikkim Himalayas. So, particularly here we have analyzed the boundaries of the glacial lake between 1989 to 2022, and here you can see different boundaries are marked. So, here red color is the base map for us, it is 1989, and the purple is 2022. And you see many of them are increasing in the size, some of them have vanished here. This particular graph can be used to analyze which of these lakes are growing rapidly, and here you can see this table, it says that TL11. If you refer to my paper, you will understand which one is the TL11. So, link is given at the end of this lecture. So, this particular glacial lake has vanished. So, it is not always growing. So, some of the glaciers are not melting rapidly, some of them are melting. As a result of that, in the lower reaches you will have the formation or vanish of glacial lakes, right. So, to understand it thoroughly, let us go through this basic detail. The accumulation of glacier meltwater unable to flow naturally due to barriers like ice dams, bedrock or moraines result in the creation of glacial lakes, right. Due to the climatic condition changing, retreating glaciers leading to the formation of more glacial lakes and an increase in their size. The failure of such moraine dams through breaching or overtopping suddenly releases a large amount of water in the downstream. A sudden release of meltwater from a glacial lake results in a catastrophic flood known as GLOF. Due to the changing climatic condition and topography, glacial lakes are more susceptible to GLOFs, right. So, here you can see this particular image is showing how devastating a particular lake failure can be, right. So, on October 4th, Sikkim in northeast India experienced a devastating glacial lake outburst flood triggered by intense rainfall that caused a glacial lake to rupture, right. This led to a sudden rise in the Tista river's water level approximately 20 feet, resulting in extensive destruction of the infrastructure, homes and loss of lives. The resulting flash flood surged downstream and struck the Tista 3 dam at Chungthang around midnight, demolishing it within minutes before the dam's gate could be opened. So, this is the example from Sikkim Himalayas, and this particular slide will help you to understand what is the need of the vulnerability assessment of these lakes. So, this is the threat to the human settlements, destruction of infrastructure, economic disruption, then environmental impact, right. So, these are the major component why we need the vulnerability assessment, and these glacial lake vulnerability can be linked to the changing climatic condition, which calls for a early warning system for a given lake which is vulnerable, which is rising its aerial extent very rapidly, right. So, here you can see the glacial lake vulnerability refers to the susceptibility of glacial lakes to outburst flood, which are sudden releases of large volume of water from these lakes. So, here you can see the examples. These floods can cause widespread damage to infrastructure and life downstream, particularly in high altitude regions like Himalayas. Now, let us try to understand why this vulnerability assessment is important. So, let us go with the minute details. It is essential to do the glacial lake vulnerability assessment and formulate effective adaptation strategies. Implementing adaptation measures in the short term can help to mitigate the risk. A thorough evaluation of both physical and socio-economic risk associated with climate change in the region is required. Vulnerability assessment is an important step to understand and reduce the dangers caused by glacial lake outburst flood. I have covered the GLOF in detail in the previous lecture. Vulnerability assessment helps to pinpoint which area are most likely to be impacted by the GLOF, considering factor like size of the glacial lake, stability of the dam and the presence of the settlement and infrastructure in the downstream areas. It assesses the potential consequences of a GLOF, including the extent of flooding, damage to infrastructure and potential for loss of life. Vulnerability assessment is the process of identifying, quantifying and prioritizing the vulnerabilities in a system. Vulnerability is defined as the extent to which climate change may damage or harm a system. It is a function of both sensitivity to climate and the ability to adapt to new condition. So, it is not always going in the negative direction. Because of this changing climatic condition, the lake or the area can adapt a new condition, that will be a new normal condition. For the vulnerability analysis, various satellite products including DEMs are used. A land use land cover map LULC of the study areas showing in situ observation is serving as a driving factor for the vulnerability analysis, right. So, what are the different indicators of vulnerability? So, we have physical indicator, then we have economic indicator, social indicator, environmental indicator, institutional indicators. So, in physical indicator, the location of settlements in hazard prone areas are studied, quality of housing and infrastructure, accessibility to emergency services, that comes under the physical indicator. In economic indicator, the income levels, employment rates, agriculture and tourism, that will be there. In social indicator, population density, age and gender distribution, education and literacy rate, health status and access to health care, these are the components of the social indicator. When we talk about the environmental indicator, we have degradation of natural resources, deforestation and land use changes, water availability and the quality of the water, right, which is available to the people. Then comes the institutional indicator, disaster preparedness and response, availability of early warning system, governance and policy effectiveness. How government is responding or how a particular agency is responding to this disaster, right. So, the vulnerability indicators are measurable factors used to assess the degree to which a system, community or environment is susceptible to harm from hazards, right. So, here you can see the different indicators are mentioned here. For example, the lake size, moraine, slope, stability, proximity to settlement area, these can be indicator of glacial lakes, right. The physical vulnerability, so here it refers to the degree to which a location is at risk from a potential event. This risk is influenced by the nature of the hazard such as a glacial lake outburst as well as the event's magnitude and its likelihood of occurrence, right. The physical vulnerability indicators are the magnitude, lake outburst probability and the trajectory, right, and also population density. The social vulnerability, it arises when unfavorable social condition increase the risk to an individual's life or livelihood from specific and identifiable event related to health, the environment or the society. It is commonly assessed using an index that combines various social indicators. So, here when we talk about the social vulnerability in glacial lake vulnerability assessment, we have population exposure, socioeconomic status, access to infrastructure, social demographics and the livelihood dependence. So, these are the indicators, the social indicators, right. Then components of the social vulnerability, we have preparedness, prevention and the response, right. So, in the preparedness, it refers to the state of being prepared as an individual or a community in a disaster. Prevention refers to measures taken to avoid or minimize the adverse impact of hazard and can be divided into structural and non-structural measures. And the response, it means the capability to recover from a natural disaster, including immediate reaction after the long term coping with such event. So, here we are talking about the preparedness, prevention and the response in general, but now you can relate it with the glacial lake vulnerability. So, when we talk about the glacial lake vulnerability analysis method, so we have remote sensing and GIS based mapping. So, here the multi-temporal satellite data are used for lake delineation and change detection, and many other techniques like classification and NDVIs that can be used to identify or precisely mark the boundaries of the glacial lake. Then comes the field observation and validation, because whatever we extract from remote sensing data, that has to be validated in the field, then only you will be confident about your results. Topographic and bathymetric analysis, since we are talking about the glacial lake, the surface extent is one thing, but you also need to have the understanding on the volume of the water which is stored in the glacial lake. For that, the bathymetry analysis is very important, right. Then comes the hydrodynamic and GLOF modeling that we have seen in the previous lecture. Then comes the risk and vulnerability indexing, right, and then climate change impact assessment, how and why we are having this kind of natural lake disasters, right. So, let us try to understand the risk indexing for glacial lakes. So, risk indexing for glacial lake is important for systematically assessing and managing the hazard associated with the glacial lake outburst flood. Due to climate change and global warming, glacier retreat and melts and the water accumulates in glacial lakes, right. And these glacial lakes are held by moraine or an ice dam structure, which poses the potential for sudden catastrophic flooding. By using the risk indexing, it becomes possible to systematically identify the glacial lake that are prone to outburst and to prioritize these for monitoring from these remote sensing data sets or from the field investigation. This proactive approach is crucial for minimizing the loss of life and saving the property, right. It also assesses the development of early warning system, because that will be a part of early warning system, and long term climate adaptation strategies, making it a crucial tool in mitigating the impacts of glacial lake hazard in vulnerability analysis. So, the factors which are associated with the risk assessment of the glacial lakes. So, here we have the size of the glacial lake, type of the glacial lake, change in size of the glacial lake with time, stability of lake side slope, right. Then comes the upstream of glacial lake. What is the condition of the glaciers? So, the snout to glacial lake distance, snout to glacial lake slope, glacial lake in the vicinity of connected within 1 kilometer in the same valley. So, how many glacial lakes are connected? How many glaciers are feeding a particular lake? These things are very, very important. Then downstream of glacial lake, here distance to nearest habitation likely to be affected, distance from nearest dam, distance from nearest bridge. So, what could be the impact of a catastrophic flooding if this glacial lake fails? So, that can be seen by this downstream of the glacial lake. Then other parameter like historical Gulf event, seismicity in that particular area, that will help you to understand how vulnerable your glacial lake is to the Gulf, right. The factors which are associated here, so let us see one by one. Size of the glacial lake, type of the glacial lake, lake over time, right, how they are changing with respect to time, stability of lake side slope, then snout to glacial lake distance, snout to glacial lake slope, then comes the connected glacial lakes within 1 kilometer, then distance to nearest habitation likely to be affected, distance from nearest dam, then distance from nearest bridge, because these are the things which are very critical. After the flooding event, we have to have the communication to that particular area. So, the criteria for identifying the potential Gulf. So, the potentially dangerous glacial lakes can be identified through field investigation, analysis of processes and records of past events. If a particular lake has a history of Gulf, right. Assessment of the geomorphological and geotechnical characteristics of the lake and its surrounding. So, here basically we are talking about the moraines, right. Evaluation of other physical condition. So, rise in lake water level, then lake position, and then the dam condition, the moraine condition, right. The mother glacier condition, whether it is having the impact of the climate change, then you can expect more melt water to a glacier's lake, right. Then surrounding physical condition, so nearest rock fall or snow avalanches, seismicity or neotectonic activities, climate shift, newly formed moraines, then sudden glacier avalanche near well developed lakes. So, that will trigger this Gulf event. So, these are the different criterias how we evaluate the vulnerability of a glacial lakes. So, with this I will end this part 1 of this lecture and we will continue this one in the next lecture. Thank you.